Hello, everybody. Thanks to all the friends joining us now, and good evening to everybody in Australia, Sydney, Melbourne, or any other cities, and everyone else from all around the world if you are joining us for our April virtual meetup. Thanks for being us again. As usual, it's a Azure Sydney user group, and then for the first part, we go for the what's new in Azure since the last time we met. Uh, we will talk about the upcoming events and then Azure Developer News by myself. I'm Sam Alevi from the Telstra Purple. And then we have a guest speaker from the other side of the world, from Canada, and which is really much appreciated for joining us and giving us this session, which is going to be very cool. There are two major events, both by Microsoft, in which you can join. They are online and virtual. So the first one is the Cloud Skill Hub, and which is going for a couple of days, and then you can define which track you want to join, and then check the agenda based on the links which you can see on the screen, and go for different sessions from the fundamentals and different type of the sessions, all about the Azure and different services, different type and variety of workloads or projects or anything you can do with the Microsoft Azure Cloud Platform. The second one is which is another major event by Microsoft again. If you are a developer, you should be familiar with the MS Build event. So this year also again happening virtual. It's full online. It's going for 3 full days, and the session and agenda is already published. You can go and check on the MS Builds, and there are heaps of cool announcements going to happen within the Microsoft MS Build this year for 2021. As usual, we go for a couple of announcements. This month, there is a small number of announcements all around public preview and the GA, which we can go through them quickly before the main session. As part of the public preview, there is a long-awaited feature already available in Australia, which is Azure Active Directory B2C. It's now available in Australia, and now we can use it. Starting April 9 this year, we can use, create, and host the Azure Active Directory B2C instances within Azure Australian data centers. And that means you can keep your user data and anything related to their authentication for the Azure B2C inside Australia, rather than previous instances going and hosted outside Australia. The second one in the public preview is Azure Functions, and for within the Azure Monitor. In Azure Monitor, basically a function is a log query that can be used in other queries when you create in the Azure Monitor in the log queries as a command, which is a great feature in reusability as a normal functions in programming languages. Now it enhanced by 3 new major features, and new experience is added in the Azure Monitor and with the log analytics sidebar, which we can see easily discover and use the functions available and exposed. The second one is now we'll be able to access solution functions, which are pre-built Azure functions, Azure Monitor functions that are used across the solutions and insights. Now they are all publicly available and we can use them, discover them. And the third one is the support is added for parameters in the workspace functions, which means, and it enables us to create our own function with parameters in our workspaces. The third one is the cognitive services anomaly detector updates. Basically, it's an update around the anomaly detector API, which is a member of cognitive services. And now it's enhanced by a new feature that Microsoft called it and referred to it as a multivariate anomaly detector API or feature. And that means it further enables developers to easily integrate advanced AI capabilities of detecting anomalies from group metrics into their application. Also, another big advantage is it doesn't need any machine learning knowledge, which is pretty cool for adding anomaly detection into applications, different type of applications. The fourth one is another interesting project from Microsoft, and basically it's called, Microsoft is building a Java OpenJDK. It's a new, still in preview, build of the OpenJDK, fully and completely done by Microsoft. It's fully open source, everybody can contribute, and Microsoft is the main maintainer. But the big advantage is it comes as a no cost with the long-term service support, and it's a long-term service support, no-cost distribution of standard OpenJDK, which is fully open source, as I mentioned, and free for anyone to deploy to any platform. It contains Java 11 libraries as of now in preview, and you can use it to deploy to different 64-bit servers, desktop, macOS, Linux, or Windows machines. As part of the GA updates, one of the important one is around the application gateway, Azure Application Gateway, and the new capabilities added, and it's GA now, which is called URL rewrite capabilities. By this feature in Application Gateway, now we could write host name, path, and query a string of the request URL, which is coming from the client side. That means in addition to the header rewrites, which was available already, we can now rewrite the URL of the client request, and based on matching and different conditions. And we can also choose to route to different requests based on conditions, or based on original URL, or even the rewritten URL after the rewrite rule is applied, which is another cool feature inside the application gateway for enabling application gateway for multiple workloads or pointing to different multiple applications but using the same instance. Open source API portal is another interesting project, again from Microsoft, and basically it's a new and independent feature, extra independent from API management, which lets you create and publish a customized site with API documentation totally for free without any writing code. It builds on top of GitHub pages, and with the GitHub-based workflow, it enables collaboration between API providers, API consumers, source control enabled API and documentation, and automation also with using GitHub Actions. And it's free for hosting because you host it in the GitHub, which is another cool. But the backbone, and it's based on the API developer portal, which is already available and customizable inside the API management. But it doesn't mean it requires API management instance if you want to just use it for documentation or exposing your APIs to outside. Another feature is cognitive services. Basically, the computer vision API now is GA with version 3.2. It also offers few enhancements and updates. Three important of these are improved image tagging model. So it comes with the improved image tagging model. It updated the content moderation model, which is very useful for detecting, for example, adults and in a different variety. And the third one is the OCR API, also updated with 73 different languages. So it comes, the OCR APIs as part of this comes with 73 language support. Another update in the GA is API management got the availability zone support. So if you are familiar with Azure availability zones, they are to provide high availability for your mission critical applications and the data. Now, this capability is added and it's available in GA for all the regions and all the data centers across all the Azure regions and data centers for API management instances. And that means we can achieve a high availability of API management instances at a different for a different deployment model. For example, if you have API management in a standard tier and deployed in a single region, we can achieve high availability by enabling availability zone in that region. If availability zone obviously is available in that region, or we can achieve high availability in the primary region when it's a multi-region deployed instance, or we can achieve high availability in every single region of multi-region deploy instances, which is cool, and it makes sure that API management instances are highly available regardless of the deployment model. Another update is around the Azure Map services. And basically, one of the member of this service, which is a PaaS service, Azure Maps is another of PaaS services from the Azure, is the weather service. And weather service part now uses the global data from worldwide weather service provider, which all of us know as called AccuWeather. So the data from this service provider now globally is being used by Azure Weather Services as part of the map services, and it offers a reliable and easy way for developers to bring and integrate the weather content for their users and for their applications, which is another cool feature as part of the PaaS services. Another feature is around the Azure storage. Azure Blob Storage now supports up to 200 terabyte object size. That means we can utilize Azure Blob Storage and Azure Data Lake Services Generation 2 for workload that requires larger file size without breaking those larger files into separate blobs. Before this feature, we have to break them into a smaller chunk, but now with this feature GA, we don't need to break, and we can have a chunk of up to 200 terabyte object size stored in the Azure Data Lake Services Gen 2. Another update is for app service. And basically, there is a feature in the app service called authentication and authorization, if you remember from the portal, which you can configure. And basically, is a feature of app service that allows applications to log in users and require that request of the application to be authenticated using federated identity providers like Auth0 or Azure Active Directory or Azure Active Directory B2C, and etc. Any other identity provider which they support with the app service. With this GA update, this experience got a new version as part of that, and which contains usability improvement and setup and works differently with Microsoft Identity Platform also. The previous experience, which is already in Azure Portal, has been renamed now and called and referred to as the Authenticate Classic in bracket if you want to still use the old version. But by default, when you go and enable this feature for new created app services, it goes with the new experience, and you get all the capabilities and features and experience from this new feature. But still, the old one is still available, but with a different naming as a new renamed feature. But it's still available to use if you want. So since last month, these are the old number of updates available for us in preview and GA. If there is any question, please raise them in the question box, and we can get back and answer them. Otherwise, I move to another slide, which is announcement and useful links. If you are not familiar already with the New Breakpoint is a new video cast all done by Microsoft Australia team, and it's hosted by Simon Wade, another fellow which time to time join us here in user group. Also, I'm sure he's a familiar name and face to many of us here. And basically, it's all about learning what's happening new in Azure, learning new things and new cool stuff, and happening by Azure Grows in within the Australia. That's a cool video cast. It goes live every Thursday at 11, and that's good if you can join and watch for 15 minutes or 20 minutes each episode. Normally long last. The second one is, as usual, the community newsletter. Again, it's effort done by Microsoft Australia, Simon's team, and basically it's a tailored newsletter for Azure developers. And basically, it's a picked version of the community's events and all the cool stuff which you can get in a single and shortened version. At the end of this session also, we have a number of Azure paths which we can give away if you want to try, for example, today's session by Bruno or any other cool, or if you want to implement a POC, or even if you are completely newbie to Azure, we can provide these Azure passes, and then you can go give it a try and start experiencing Microsoft Azure. So far, these are the updates and basically all the news from the first part. If there is any question, anything, please raise and we can get back to that. Otherwise, we can take a break for probably a couple of minutes. And then we have El Bruno from Canada. He's a Microsoft MVP in AI. And share the link to API source API portal. Yep, I'll definitely can do that. Once we get into the main session and Bruno start the session, I'll put the link to that in the chat box for everybody. Yep, it's really appreciated effort from Bruno. So it's already 3 or 4 a.m. from the other side of the world. So it's much appreciated for being with us and presenting to our Azure users down under in the Australia. Thank you, everyone. And in a couple of minutes, we jump on the main session. Thanks.
Perfect. So I think we are live. Can you confirm if you can hear me fine and you can see my screen? Perfect. It seems that we are up and running. So, hey, thank you very much. Bruno Capuano here from Canada. It's a pleasure to be with you today in the other side of the world, literally. And hey, this gives me back the chance to share with you one of the sessions that I really love to talk because it's an ongoing process and it's how I am working with computer vision projects and how I use a couple of Azure tools and community services to make this happen. And it all started at home and then become a startup that I'm working with colleagues and also with clients. So first of all, let me introduce myself. My name is Bruno Capuano. I live in Canada. You probably noticed the accent. I'm not Canadian. I came from Spain. I've been here in Canada 5 months. And hey, I love to have this picture here at the beginning of the session that reminds me that this is not Canada. Yesterday morning, we have an amazing sunny day. Now it's snowing. I have a white backyard here. So this is what we are doing. I've been an MVP for over 13 years, I think so. In the last couple of years, I've been an MVP in the AI. I am not a data scientist. I am kind of an enthusiast. I've been a programmer, a developer for all my life, and I get here mostly by learning. And today, what I want to share with you, what I want to share is a couple of topics. And I know I am going to talk about my life. You're going to see how I get here. Then I'm going to talk a little about a couple of tools and techniques to do computer vision and image recognition. And then going back to the main part about how we can use Azure IoT, the tools that I'm using here, and demos. I try to do everything live, so I have a crappy setup here doing stuff because we are moving. I am moving to a new house in a couple of weeks, so my house is a mess right now. So I managed to have everything up and running here in my temporary office. So I hope that you get the feeling of what I want to do. At the beginning, I always start with this. Sorry about the bad jokes. Sorry about the bad demos and the crappy animations. Don't do this in productions. I will share the code. I will share the slides, but this is not what you expect. And this is the final demo that we are going to build. I'm just going to share with you a video, but what I built as a prototype and started here was basically this was a toy, a garage, a parking lot that you can buy as a toy, and with the camera, I was spotting the empty places that we have here to try to figure out which ones are free or not. We are going to build this, a very similar one for at the end of the session. And you can see here it's not super accurate, so I will share with you a couple of techniques of how we can improve this, how we can get this up and running, and how we can even get here. This is what I used to do when we have live events. I bring this to the stage, I have a couple of cameras on top, and I show how we can do this. And how we start this, how it all started. So it all started 5 years ago or so when we moved to a new house here in Canada, and we get a cat. We get an amazing and funny cat. His name was Goku, and we have a lot of fun with the cat. We love our cat, but he used to go outside and chase and basically hunt little animals. He was hunting mice, little birds, and other animals, and he brings the animal home. So my wife asked me if we can do something to try to avoid him bringing these animals to the house. And I said, yes, we have cameras all around the house. We have a lot of stuff here. So maybe I can create, this was my beginnings, the computer vision, we can create some kind of tool or whatever to identify a cat, to identify when he is arriving and try to see what we have, and when there is a cat, the cat is bringing something, and oh my God, this is supposed to be an easy path, but it wasn't easy at all. At the end of the day, I realized that when you start to do computer vision, you have kind of two flavors. You have a package service, like the Azure Community Service, when you have package service to do to do, in example, speech recognition, or you can analyze language, or you can do computer vision, and it will detect something. And then you have a model that you need to create everything from your own. You can use Python, you can use TensorFlow, you can create your own computer vision solutions, but it requires a lot of code, a lot of really working there and really doing all of your codes. And I need something in the middle. I need something that, hey, I don't want a package one because it's not fitting my needs, but I don't want to also to create something from the scratch. I don't want to start to code a lot here. And lucky for us, in this middle line, we have a service from machine learning, from the community services, that basically do the ABC for machine learning, which is, in machine learning, we basically do always. We work with data, we prepare our data, we clean the data, we refine our data, we spend a lot of time trying to get a good data sets. Then with that data set, we start to build the model. So we build the model, we train, we iterate, we test. And then when we have a model, we can start to use this model. We can start to run this with the model. And as I mentioned, in the community services world, we have, for computer vision, one of the services which is called Custom Vision, that basically allows us to do this ABC. Because we can start uploading images, which is going to be our data. So we upload our images, we tag our images, we refine the images that we have, then we train a computer vision model. With those images that we upload and tag, we can train this model, and then we can start to use this and evaluate. And this is the part that becomes basically super important, because we can use this as an endpoint on the cloud. So we can publish this to be used on the cloud, where you are going to have an HTTP endpoint, and you can submit your request there and have information. Or we can download these models to be used in Docker, in, I don't know, in Onyx, or TensorFlow models, or other formats, so we can reuse it. And it's super easy and it's super fast. So when I started to play around here, of course, my first request, where I can get data, where I can get images. So I went to Kaggle. Kaggle is an amazing place. You can find a lot of challenge. We can find a lot of, I love this because there's a lot of challenge here around doing mostly machine learning, solving machine learning problems. But also we have here a lot of prepackaged data sets. So in example, you can download these 4 gigabytes of images of people inside their cars driving, and also doing stuff like drinking or talking in the phones or texting. And then you have all of the images tagged, so you can upload these to computer vision. In this example, I did example uploading for safe driving, for texting, or for talking on the right hand, talking on the left hand, texting with the right hand, texting with the left hand, drinking. I can't remember. I think it was 10 different categories. You can upload these to Custom Vision, upload your images, and then you train the model. Then when you have it here, you can say, okay, let's train this, and it's going to upload the images, train the model, and we are going to have, at the end, kind of a chart like this one, which is going to basically set back to us, okay, I trained your model, this is a couple of metrics around your model, I have this precision, recall, and IP, which is kind of nice, and we'll also have a public endpoint if you want to use this. And it's super easy, and again, I started with Kaggle to do the extractor driver, but let's stop the slides and let's do a real one. By the way, this is the destructor driver. I'm going to, everything that I'm showing today, I'm going to share it later in the slides and the resources. And this is a 4 gigabyte data set with all of the images that I just mentioned. But let's create our first Custom Vision project. So Custom Vision main URL is customvision.ai. This is what we are using to work here. Let me pause here. I don't need to have this syncing point, right? So we have customvision.ai, and let's create a new project. Custom Vision, again, is part of the community services, the Azure community services. You can test this for free with an Azure account. You can have a free trial and test this. And when you create a new project, what you need to do, let's do this Azure drawing. And when you create a new project, you can basically use one of your subscription. I have one for demos. And then we have here a couple of projects types to create. We can do classification, which is basically we are going to upload images, and the images are going to be simple tab or multi-tab in this classification. Or we can do object detection, where we are loading images and we select in the image different objects there. So if we do classification, that's going to do. I am going to, for this demo, I am going to just use one tag per image. So each one of the images is going to represent one tag. And then we have some kind of domains here, like generals, general foods, and general compact. This is kind of a external, kind of template that we can use. And if you go for the compact mode, for the general, then we have the export capabilities. So I can export my trained model, my trained model to TensorFlow, Onyx, and other elements. So let's start with the with a simple tag image. So first step, as I mentioned, was let's upload a couple of images here. Let's add some images. So I am going to upload a couple of images. Let me go to my simple model, and what I am going to do, I am going to upload just drawings. This is just simple drawings of fish. I will create a new tag, which is going to be called fish. Once it's uploaded, I have my first 8 images here of fishes. And by the way, this is very simple image tagging that I have here. And I will add a new set of drawings for flower. Same process, I can add this to my previous tag, but I have here flower, so I have a new set of tags. I already have here in the left, you can see my tags, and I will add a third batch of images for humans. Let's go for human. And of course, here I can add new images, I can add negative values. This is a new tag. So I will have here my set of images with my humans, my fish, and my flowers. And what I can do right now is I can train my model. So I can go here, train my model. It will take a couple of seconds. Unless I have something weird here, it should be super fast. But the idea is that once I am training my model, this is training a computer vision model that I can use to analyze and to later analyze images. So let's give this a couple of seconds, and I will take advantage to drink some coffee. Okay, while this is training, what I am going to do, I am going to open one of the most powerful tools that we have here in the Windows world, which is the Paint. Where is my Paint? Where is my Paint? And I am going to start to do some testing drawing. So I am going to, sorry about my drawing skills, I am going to draw a fish. So this is a fish, and let's do this for Australia. Let me save this in the desktop. Fishy, then I will do I will do also a human. Let me also sign this for Australia, so it's yours. And let's create something that doesn't make any sense. I don't know. Something like this. No sense. So I say 3 images. This is still training. I know sometimes, I don't know why sometimes, because I am using the free training model usage. Sometimes it takes a lot, so I already have this trained here. When you have the model trained, what you will have is something like this, where you have your images, where you have your output on your precision. So we can see that after I train my model with the same set of images that I use this, I will have this, and I can test this. I can go quickly to test. I can upload a couple of files. Let me go here and upload the drawing that I just made. So let's upload the fish, and it will analyze this. And as we can see here, we are the model that we just trained is 99.9 sure that this is a fish. And it makes sense because I am working with lines, black and white drawing, so it's very easy. It should be work great in each one of these. The humans will be probably kind of different. It's kind of fine, 99. And even if I go here to the third one, to the no sense, let's try to figure out. So somehow it understands that this is a human. So let me show you. Somehow it understands that this is a human. 92% is not a human. So what I probably need to do here is train this model again with something else. And if let me try to see if I can draw. I can draw a flower. Sorry for my drawing skills. So this is a flower, the ugliest flower ever. But if I go back here and I will select the flower, there it is. Take a look here. It's not completely sure that it's a flower. Somehow it's also a fish. But hey, it's up to us as a developer to try to figure out what we have and say, okay, I'm only going to trust this when it's only, I don't know, 90% or bigger or something like this. The cool thing about this is, as I mentioned, I can go back here and start to test this. So I can use this and add this into my training as, hey, this is a negative value. So I can add this to my training sets. I can go back here and say, you know what, this is a flower. I will save it. And the same with the fish. And I will save it. And I will do the same with the human. I save this. And with this, I will have more images here to train. So I have 1 negative and 9 for each one of the labels, and I can train this again. It's going to say that I can train because I need at least 5 images for each tag, so I need to add a couple more in the negative value, but I can use my model and make my model smarter, and I can train with more images until I get a decent model. And the cool part here is that at any moment when I have one trained model, I can export these models. And I am going to show you later. This is the part that we are going to use. But I can export this model to be used, in example, as an Onyx file. I can go here, I use an Onyx, export, and it's going to give me the chance to download this and to use this locally in any kind of Onyx supported environment like Windows or Python or Linux or whatever. Or I can go and export this as a Docker file. It's going to give me the chance to export this as a Docker image for Linux or for Windows or even for Raspberry Pi in an ARM model, and I can download and use this. But at any moment here, what I can do, I can publish my model. I can publish this model in my resource, and when I do this, I am going to have a prediction URL. And this prediction URL is going to give me the chance to make these, to analyze these images, to do this. So I can pick up this URL. I can open a tool like Postman, in example. And I can use Postman to make a post to that URL with an image. Go back overview, go back release note. I can create a new one. This is going to be a post request for that URL, and I need to add a couple of headers here. So I need to add a prediction key header. So let's go to headers, prediction key with this value. And I also need to add a content type. Content type to define, and this is going to be an upstream. This is going to be a file, and in my body, I will add a file. Let's add a new image here. Let's do, I don't know, let's do another flower. Let's go to see, this is flower number 2. So, flower 2. So here in my body, I will select this flower, I will select the flower number 2. Let me go back here to my desktop. This is the flower number 2, I will open this, and I will post this. So this is going to post this to my public endpoint that is just created, and I will have this result. And take a look here at the results. In the results, I have a prediction, and I have a 71% prediction that this is a flower, a 22% prediction that this is a fish, and a very, very low one that this is a human. But I didn't write any line of code, and I created a system that allows me to basically do this analysis online, analyze these images online, and even I get an endpoint on the cloud that I can use to do this, that I can use to basically run and do the analysis of the images. And it's super cool. I mean, I can from here start to do something else. Even if I want to try this to see if it's real, I can go to do a quick test, select the flower, the second flower, analyze this, and we are going to have the same similar value here. So we have 71% for the flower, 22% for the fish, and the human. But the important topic here is that, hey, I can do everything without any write a line of code, and I can start to use this. And if you ask me how we can use this in example in a real scenario, let me show you one project that we created. So we were working internally in Avanade, and in a construction site, in example, we have this request around what we can do. Let me hide my camera here. What you can do in order to check if the employees are wearing their PPE, like the helmet, the safe, the glasses, and all of the stuff. So at the beginning, we started to see that we can create a system to my slides are not working. Give me a second. We can create a system to basically train a custom model using deep neural network to analyze people, detect faces, and then check. We started to do a lot with using two approaches. One, using the custom create. We write a lot of code to do this analysis, to identify this, and also we do this with the custom vision service. So we basically train with 900 or 1,000 images of people wearing helmets, people wearing vests, vest on, vest off. We have a lot of images, and we have a decent scenario where we can, let me view this, where we basically create an app, and this app is going to run locally, and it's when you step in front of the camera, it's going to quickly detect if you have the helmet or the vest, and you are going to have the green or the gold. And again, with the two approach, it basically took us a lot of time to see what we have, a lot of time to see what we can do, doing custom dev, but we get to a point that, hey, we can run this and we can use this, because I also, as I mentioned, no lines of code, you can create an endpoint and you can even use it in the cloud. Before going there, before showing there the cloud, let me show you one another important stuff here. I have the chance at any moment to export this, as I mentioned. And we can export this for TensorFlow, CoreML, but I like the Docker approach. I like to go here and export this as a Linux approach, because at any moment, what I can do is I can create this image, I can download this image, and I can use this as a Docker image file. So what I have here is I just download an image of Docker that I can use to do this. So if I go back to an example, this is my machine. Let me go back here. If I go back to my downloads, I have one download here that is the one, this is the zip file that I download, and this is a Docker file. This is a Docker, let me do this in the Windows environment so we understand what we are doing. So this is the two downloads, and this is the Docker file that I just have here. So as you see here, I have an app, I have everything here. Let's install this. Let's do this. Drawings, Australia, iteration 1. So I basically copied this to a Docker folder, and I am going to open this in Visual Studio Code so we can take a look at what we have here. So we have a file. The file is the Docker file. The file is super easy. The file basically shows the base that we are going to have. Use is going to be a Python 3 slim image, and then install a couple of dependencies, NumPy, TensorFlow, Flask, and Pillows, and then we have an app here. In this app folder, we can find our app. Our app is going to be an endpoint, an HTTP web application that is going to have two roots, image and URL. We can post here an image, or we can post the location and URL, and it's going to analyze, and it's going to do exactly the same that we did with the web. We can run this locally, and we can basically install this to run and do the image analysis. So I can go back here, and by the way, this is the model PB. This is the file that we have here. This is the big file. This is the trained model. It's a 4 megabytes. It's kind of simple, but this is the one that we have, and I can install locally. Let's do this. Let's install this locally. So this is my local file. Let's take a look at the name. Let's go to drawings, and let me build this. Let's call this, I don't know, Azure Australia drawings. So let's build this image. This will take a couple of seconds. Oh, I think I should have this off. We're going to take more than 2 seconds, so I will drink some water. There it is. The model is building. It's done. And let me also run this Azure Australia drawings. Let me run this. Oh, I already have something running in the 84th. Let me stop this one. Sorry. There it is. So I will run my model. So my model is running in the port 80. So if I go here, this is my model running to do the image recognition. And what I can do now, I can basically pick up the Postman project that I created before. Instead of using this URL, I am going to use the smaller one, I am going to use my local host.image. I am going to also add a header. I don't need the key, but I need the content type. So I will go here in my header, add content type, application hog stream, and in the body, I will add the same image, flower number 2. So when I post this, I am post this to my local Docker container that is running, and it's going to analyze the image. And as you can see here, I have similar values. I have a very similar values, and I think I exported a different version. But for this one, I have a human. It's 9. I'm sorry. I have 54% that this is a flower, which is kind of nice. 36% that this is a fish, and a very low one for a human. But I can still run this, and remember, this is a model that I train in the cloud, exported, and I'm running it locally here. And I can even go back here and start to see how this works. If I go back to Docker, not here, sorry, I am going to see in the logs. We can see here in the logs that this is the Docker container running. This is using this and using the image. This is what we found. So every image that I post here, it will be analyzed and run back. And hey, I am not using resources in the cloud. I am not going back here to do my predictions. I am using a local container to analyze this. So this is kind of the intro of what we can use. We can train models in the cloud. We can train complex model in the cloud. This is a simple one with images, but here it is. It's kind of nice. And then we can use it to analyze, and we can export this model. We can analyze how we can move this forward. What else we can do here to have a better experience, to have a better understanding. So this is the moment that I start to talk about, okay, let me show you the story about the parking lot. Let me show you what we can do with the parking lot. So I've seen this amazing video. It's going to be a little, let me remove myself. So I've seen this amazing video where you can see these cars here and how they are parking in a parking lot, and how they are going in and out of this parking lot with a very high camera. So I started to think, okay, this is fine, this is nice. And I see a couple of demos of people doing computer vision on top of this and detecting the empty spots and how you can create this spot, how you can get this green or red spot when you detect this. And I say, okay, what we can do, how we can use this, how we can start to really do these kind of things. So at the end, what I started to think, hey, you know what? It's not going to be easy to have this aerial camera. I mean, you can have it, but if you have some security cameras, if you have some the standard security cameras that you have in a parking, you can start to check for empty spaces. You're going to start to see if, in example, in a train station, you have a train or you don't have a train, or in the parking lot, if you have these empty spaces or not. If you find the empty space, that means that there is no car. If you can't find the empty space, there is something here, a car, a human, or something else. So we can start to do this, and we can use this computer vision capability to analyze this in train stations, bus stations, malls, to analyze objects in the counter, to do some waiting lines analysis. And again, you don't need to write any custom code. You can write this of your own. So what I did here is, at the beginning of this, when I was starting, I have this, as you see in the video, I have this toy here, the parking lot, and I put the camera and I started to play around with this. And it was kind of something like this. I have my camera, I have the tripod, it was a mess, and I'm taking photos. And with this, I did the first video. but it was kind of cool because we have it up and running. But what we have today, because as I mentioned, I am moving to a new house, so I couldn't find this, I couldn't make the setup. I did something similar for today, which is this. I don't have the parking lots available here, but I have this camera. I have two cameras just in case on top of a parking lot garage here, and I will going to show you how we can analyze this. So if I open my camera, you can see here, this is my camera, and this is myself playing with my cars. I have a couple of toy cars here that I can use. And hey, this is my garage. This is my fictitious garage that I have with my camera on top to analyze if we have cars or not. And I created a model. I created a machine learning model in Custom Vision. If I go here, this is a different model. I didn't tag each one of the images here. What I have here is I use, I don't know, I think it was 40 or 50 images. And I tag here and I select each one of the images. So I can select this and apply a new tag for corner, but I am not going to do this. But I select each one of these and this is spot number 1, this is spot number 3, spot number 4, garage. Let me remove this. We don't need this. Remove this. And I can start to add this. I use some images in landscape, another twisted. I have some of them with cars, some without cars in the bottom, some with very high lights, some with low lights. And hey, this is kind of working. At any moment, I can go back, in example, to my camera. I train my model, but I can go back to my camera, do something like this, take a photo. So I have already this as a photo, and I can go here and make a quick test. If I go here to my project, and let me go to my camera roll, and I upload the photo that I just take, it will detect the garage on top. It will detect the number 1, 2, 3, 4 here, the spots with kind of a high level. The spot number 2, this is not 2, this is 1. As you can see here, I have detected 2 times spot number 2. Spot number 4 is fine. This is not 2, this is 1. So I probably need to retrain this and add this as a new value. If I increase my threshold, I only have 3 elements detected, 3, 2, and 4. The garage is not on the top, but this is working. Let's do another demo so you can see that this is live. So let me park a car. I will put the other one here. I will put my hand here. So this is the latest photo. And let's analyze this. Close the camera. So this is the one that I just put here. So here we have spot 2, spot 4. And if I don't lower the threshold, we also have spot 1. Garage B is not detected, but you have the idea. You have the idea that, hey, I trained this model, and I can even go back here with my predictions, start to confirm this. This is spot 2, fine. This is spot 2. This is a spot 1, spot 3, spot 4, so this is fine. I can save this, and I can say, okay, this is fine. I want this as it changes, confirm it, send with this one, spot 1, spot 2, spot 4, so that's fine. I have the 1, 2, 3, and I will have this, and I can train this again if we need. I will leave this training just to show you later how we have an iteration. And once I have this trained, what we can do is let's create a system to analyze this. Let's create a system so we can use this. And I already done the ABC of uploading, downloading the model. The only thing that I need to do is, let me just in case stop this, delete these images from Docker. Remove. I want to have a clean environment. clean up. So I have a clean environment, no images, no container. And what I am going to do, as I mentioned, I am going to sorry, the latest one is parking lot 4, and I am going to build the image for my parking lot screen. I already downloaded this. I am going to build the image, and then I am going to also start the image. So the Docker image is built locally, and let's run this. Perfect, there it is. So I can go to Postman, in example, get back here. Instead of my flowers, I can go to my camera roll, pick up this one, make a post, and this is what I have in my return. And as you can see here, there is a different information here. So in example, in the detected tag, the spot number 2, I have the ID of the tag, I have the probability, and then I have the bounding box. So I know right now where I can write the frame around in the original picture. So with all of this and having this run locally, let's build a solution, let's build a project to, let's close this, let's build a project in Python so we can analyze this. So let's create a new file, let's go for host 01, let's go the 02 host event.py, copy path, let me go back here to my parking lot screen, to Sydney. So there it is, there is my file. And let's write some code here to write this. So the first thing that I'm going to use is I'm going to make some, I'm going to add some imports here. Let me increase the size of the fonts a little. And I am going to use a couple of libraries here. I'm going to use OpenCV to do the image analysis, to access the camera. And I am going to use a couple of requests for later to make the request and Flash to interact with the local Docker web server that I have here to analyze this. So the first thing that I need to do is let me init my camera. So let me go here. So I will init my camera. This is a standard Docker, OpenCV code where I am going to open my camera. I have several cameras, the one that I use for the demos and the other ones for this demo. So this is the number 1 that I have. And then what I have is I'm going to do an eternal while where I am going to open the camera and read one of the camera frames, do a resize. I don't need the camera so big, I only need it kind of smaller. I am going to save this locally just to have it later so we can take a look at what we have. And then what I am going to do with the file, let's show this. Let's show this in the frame, and let's also show the frames per second. So I am going to do some math here to show the frames per second, and then I am going to display this in the console window. The final line will be to show the camera and to show the frame, here, the frame that we have, and then I am going to wait for the letter Q on the keyboard to quit. Then I'm going to release the camera and destroy all windows. So it's very simple Python application. And when I run this, unless I make a mistake, it should open a new window. Wait a second. Should be here anytime. Or is in the other window? No, it should be here. Okay, let's continue working. This is the demo box. Oh, there it is. So you can see here, this is the camera live. I am using my hands, and we are working super fast. If I close this, this is analyzing, and this is doing kind of between 50 to 140 to 500 frames per second. So it's super fast. And again, how this works, let me minimize this a little. I open the camera, and I pick up each one of the frames on the camera, do a resize of the frame. I can do this with this format or different format with a specific size. And then I save this locally. So this is an image save. And then I show the camera output. So let's do the analysis. Let's do how we can do the analysis here. So once I have the frame, this is the frame that I have from the camera, I can start to analyze the frame. So in example, I can pick up the file that I have here, and do something like this. I can open the file and read the bytes of the file, and I can call locally my Docker container to analyze this image. So I can do a request post locally, get the JSON of the results, and then process the results. How do I process the results? How do we do this? So let me complete this very quickly here. So we have the display, we have before this, let me put this before the display, and I have a function here in my helpers which basically does all the magic. I have this get prediction sourced function. Let's put this on top, and basically it's going to pick up the JSON. I'm going to pick up the JSON, sort by predictions, sort by probability, and show each one of them which is bigger than my threshold. I am going to show this in the assorted prediction. So if I run this again, takes some time to analyze, to connect to the camera and to analyze. I can have the camera doing real-time analysis using my Docker file to see which spots are available in the parking lot. I don't know why it's taking so long to start. I should probably add some sleep here. Or no, it's just taking some time to start. So let's wait. Oh, I didn't create the app. Sorry about that. I need to create an app. I need to create a Flask app just to have some context to process the request. Sorry about that. That's my mistake. Again, running the camera, and at any moment I will close Postman just in case, and I am not going to do the C# demo. So here it is, and you can see here that I have the spot 1, 2, 3. The 3 is not available. I have the spot 2, 4, and 1 free. If I release this car here, I should have most of them available. I don't detect the garage anymore. If I put my cars here in 1 and 2, the garage is detected, and then I have the 1 and the 2. So this is kind of working. This is kind of nice. I am working also in 3 frames per second, but I also create kind of a different version of this, which instead of showing the probabilities of what we find, I am drawing the bounding box. So here, once I have the probability, I pick up the bounding box, I pick up the JSON that we have, do some calculation to adjust the size of what we find, and I draw the bounding box here. Let me delete this MVP, delete this. So let's run this one, and this is going to basically do the same, but in real time it's going to analyze and show in the parking lot, where you can see here, it's going to show the bounding box. So if I start the detection process, you can see here how the garage is detected, the 1 and 2 are detected. If I move my car out, now I have the 3 detected, the garage is still there. Let's park this in the 1. Let's move out this one. You have 2, 3, and 4. So it's doing this. It's working also kind of fast, 2.63 frames per second, which is kind of nice. But again, remember, I am using this locally. I am running this internally. And I even here for this demo, and I even get add a feature where I am saving all of the detected images that I have here. I'm sorry, I'm saving all of the images that I process and all of the detected ones also. If I go here, this is each one of the images that I detected, and also the JSON file for the detected image. So you can have a log if you want on how you want to do this. So moving to the end, we have this up and running. I have the video just in case to show this, how it works. But then we came to how we can make this in production, how we can move this to enterprise. Once you have this solution, the important thing here is how you can use this and move it to the cloud. Azure IoT is an amazing service to do these kind of things. And then we have also Azure IoT Central, which is a prepackaged system that we can use, where we have out-of-the-box dashboard, graphics. It's kind of easier than Azure IoT because you have a lot of services already there. And it's super cool to do quick prototyping and even real productions. So what I have here, I created a central application, and I perform this step. So I'm sorry, here I have here a new application in Azure IoT Central. When you create an application, you have a couple of prepackaged templates that you can use for retail. When you have your devices, because you are going to connect devices to this website, you can define some templates, and you can use already existing devices like, I don't know, you have a gateway, the Rigado gateway, or you have an Azure Sphere, or you can create your own template. If you want to create your own template, you can have a name here. So an example, my device. And then you can start to create the capabilities and the model from your device. So you can say, okay, my device will have a capability. It's going to track cars detected. So it's going to be a telemetry. And it's going to also have, it's going to define the location of the camera. So this is going to be a property instead of a detection. And it's going to be the type of location, and it's going to track also, I don't know, temperature. This is going to be a telemetry, and this is going to be a temperature type of value. So when you define your model, your device template, then you can also start to define some views. You can create some views, like an example, okay, let's add some properties. And you can add a section with the properties for the location. It's going to show something like this. So you can create your own templates. I have created, let's save this. I have created a template here for the parking cam, the parking lot cam. And it basically have a lot of telemetry properties with slot 1, slot 2, slot 3, slot 4, and this all telemetry. I didn't add a lot of value. And then I have here a couple of charts where I will show the last known value of the device, and I show the values in chart, heat map, pie chart, and lines. So just we can show this. And then I went here, create a new device. I can create, and let me delete this one. Delete this device. Let's create a new device. I will name this device house 2. Out 2, I will select the template. I will say this is going to use my parking cam V6. And when I have my device and I enter my device, I will see the charts here. I will see information about the telemetry and other properties that are connected to the device. I don't have any info here, but I created another demo here, which basically do the same that we already did, but will trigger information here. So I have the scope. I have the device ID, which its name is house2, sorry for the typo. And then I have my key. Let me copy my key. And what this demo is going to do is going to open the camera, do the analysis, get all of the information. But when it's doing the analysis and drawing the bounding boxes, it's going to send a 0 or a 1 to the properties slot 1, 2, and 3. So we have this in the dashboard. So once I have this, if I run, let me go back and run this again. Let's do CLS. And I will run the 20 here. So it's registered in the device is registered there, it's opening the camera. And once the camera is open, let me also close these files. I don't need this, I don't need this. So once the camera is open and it's running there, and I start the detection, it will start to send information to the cloud. It will start to send the detection to the cloud. And at any moment, we are going to see how the cloud is changing. So it usually Azure Central refresh in every 60 seconds, a minute or two. So at any time now we will have some values in the chart. If I didn't did any mistake with the, there it is, it's showing the values. So, I see here that the 1 is in 0 because we have a car, the 2 we have empty, and the 3 is empty. If I move this one to the 3, after a couple of seconds, we should have the 3 changing also to a red one. So let's wait. And this is getting close to the, we are getting very, very close to the end. Okay, there is changing. And by the way, you see here that it's not very well formatted here. I am not showing the slot number 4s, but this is the cool thing about this portal, I'm sorry, about Azure IoT Center. I can come here, create a new version of this device, go here to my overview, change the size. Let's go 3.1. No, let's go 2.2, something like this. Save. I will publish this. So I have a new version from my device. And then when I have my device, I go here. This is the view that I have. And I can go here to my device. I can migrate my device to the latest version, the V7. And when the device is migrated, I will have new properties, new telemetry, and even new views where, hey, there it is. I have my here. And just a sample, I will assume that move this car out, move this car out. So no cars here. And at any moment, I will have the 3 slots here completely free, because in the back, this is still sending information. So as I mentioned, it refreshes every couple of seconds, but we already have here a dashboard where we can see how this is working. And by the way, this is very simple. You can create your own, there it is, everything is green. You can create your own dashboard, you can create your own stuff. So I'm getting close to the end, as I mentioned. Let me start the screens. So this is a quick recap of what we did. I talked a little about how you can do custom vision, how you can use a pre-packaged service to create these computer vision models without any line of code, how you can export this deep learning model that you created to be used, in example, in a Docker container, which is super useful, and then how you can run these predictions in Windows. I have this demo also ready to run in a Raspberry Pi, but I don't think I will have time to run this, but you can run this also in the Raspberry Pi, and then how you can trigger and connect this information to have live telemetry in something like Azure IoT Central. And then you can do connectivity, predictions. Azure IoT Central is a full new set of, it's a new topic because once you have the info there is plenty of stuff that you can do. I will share everything. By the way, I was planning to talk about Onyx, but I will avoid this. I will share everything, all of the slides, all of the stuff that we did. And remember, what we did at the beginning, this is how we started, this is how we end, and sorry about this. And if you are wondering what's happened in my house, so we didn't track the cat getting in and out with friends from the outside, but we track the cat. So this is a camera in my basement, and you can see here how the cat is detected and is tracking. So hey, my daughter and myself are happy. We track the cat. My wife is not so happy, but hey, this is what we can do. So here is my info. You can find me in my blog in elbruno.com or in Twitter. I will probably answer faster via Twitter and @elbruno. It's a pleasure. I will be open for any questions. So back to the host, back to the presenters. Okay, I will read the questions. Let me switch my camera so you have a better view. And enable the camera, sorry about that, and stop the screen. Okay, yes, I see one of the questions that is if it's able to monitor the camera, start and stop the camera using IoT device management feature. Yes, one of the features that you have in Azure IoT is the chance to send commands. So you can send commands to the device. If I have my camera connected and I have some kind of Python script, in example, or C# can be also running this, we can receive commands to say, start doing the analysis, stop doing the analysis, or something like this. So yes, you can remotely send commands to do this.
Cool. Thanks, Bruno. I'm not sure if we will get any more questions from the folks online. It's truly much appreciated, the effort. I know it's already your breakfast time, probably.
Yes, kind of.
But yeah, we really appreciate from this side of the world, from Australia. It was a great content, really cool features, demo, and the really working POC model. It was quite interesting. Thank you.
You're welcome. Oh, I see a couple of other cameras. So which camera, someone asked which camera I am using for the detection. I am using a super crappy camera. This is a $20 camera. It's not even a good one. So you don't need any kind of a specific hardware. I mean, if you have a good camera, that's fine. But if you have a standard decent camera with any image format from 640 and 4080, kind of a minimum size, you can do amazing things in computer vision. So you don't need a very powerful camera. And I see also the other question around if there is other SDK and other than Python. Yes, I have two today. I have the demos in Python and in C#, but the computer vision, the custom vision, and the Azure IoT have plenty of demos also in Node.js, in JavaScript, and Go, as far as I remember, and there are some other languages. So yes, there are other SDK available there.
Cool.
Yes, I will share. I will share some. I'm sorry. Another question is if I am sharing my links. Yes, I am going to post in my blog a recap with the slides and a link to my repo in GitHub with all of the demos that we've seen today.
Cool, that's cool. All right, I'm not sure if we can have Arafat online, but if there is no question, we can say bye to Bruno and a big thank you, a special big thanks to Bruno for this great session. Thank you.
Okay, goodbye.
Bye. All right, folks, so we are almost at the end of this month's meetup, and yep. So in terms of the giveaway, as I said earlier in this at the beginning, we have some giveaways as Azure Pass. So if you are interested in securing the Azure Pass, as Arafat mentioned in the comments, please contact us, Arafat or myself, and or even if you know anyone who is keen to get hands-on on Azure, start experiencing Azure, and they don't have any Azure credits or anything. So feel free to refer them and ask them to mention your name and the meetup month you were attending, and we make sure it will be facilitated for them to get some Azure passes and get hands-on on Azure, start experiencing and learning more on Azure. That would be fine from our side also. So that's it for this month. Thanks again for joining us. Thanks again for being with us for the last 1.5 hours, and looking forward to make planning for next month. We got some great news also as we are communicating with Microsoft Reactor for the Sydney friends and the folks attending our meetup from Sydney. Probably from the next month, we have the possibility to go in the person and have the regular meetups as we used to do before COVID days. And but watch out our space, our meetup page, and if that happens, you will notify if that happens for the next month. If so, that would be great to see you all again in person, and otherwise we will continue online as we do now. Thanks again. Good evening and good morning, good afternoon for anyone joining us from anywhere in the world, and looking forward to see you all in the next meetup next month. Thank you. Bye.